Hello. Today I will be teaching you how to graph exponentials. All exponential functions follow the equation f of x equals a times b to the power of x minus h plus k, where the a represents either a reflection, the initial amount, or a vertical stretch. And the b affects growth or decay. And the h translates the graph either to the left if it's positive or to the right if it's negative, because h is always the liar. And the k translates the graph up or down. When finding the points that you plot on the graph, it is helpful to keep in mind that many of the graphs have a common point at 0, 1. So to start graphing a function like y equals 2 to the x, I like to start by creating a table and putting points on it based on the function. So I start with putting my 0, 1, and then to go from there, you can multiply the 1 by whatever this number is. So today it's 2, and then you keep multiplying by that same 2. So now 2 times 2 is 4. And then to go backwards is just the same thing in fraction form, so it would be 1/2 and 1/4. So you just go backwards, or well, you multiply by a half and then another half. So you multiply by the inverse. So then, now that we have those points and there are no other transformations to add to the table, we can start graphing it on the graph. So we start at -2 and 1/4, and then -1 and 1/2, and then it looks like we can fit maybe a few more points, so you can just check. So you can add another one and multiply by 2, and we can. So we can go to 3, 8, and that's it. So then we just connect the points. So that is how to graph an exponential function, but it gets more complicated once you start adding in more transformations. This function, y equals 3 to the x plus 2, is adding a new component, and that is different from the last function that we did, and it's that plus 2, which is where it is in the k value, which translates the graph up or down. So we'll still start by creating a table. And plotting that first point at 0, 1. But since, and then we also multiply everything by 3. So then, now that we have looked at it like that, we now start to add in that new factor. So, since it moves the graph up or down, it affects the y values. And this is going to move it up because it has a plus sign. So you just add 2 to every y value, and that's how you get that. So then we can go and put in these values onto our graph, and you just add them to get your y value. So it would be -2 and then 2 1/9. And then -1 and 1 and -1 and 2 1/3. And then you just keep going by adding the 2 to each. Okay, so now that we have our points, you can see that the points just get closer and closer to each other as it goes down. And if we were to keep graphing it like that, they would just still go like that and pretty much look like they were going in a straight line. And they would never cross this y = 2 line. So that is called an asymptote. And the asymptote will always be the k value. So in this case, the asymptote is +2. And I like to draw it to see which lines, what I should not be crossing. So we just connect our points like usual, and we see that we will not cross the y = 2 point. For this last equation, it has all of the transformations possible in it. So I will show you how to graph a function with every single transformation. So we start the same way that we have with the last equations, by plotting that 1 point. Then, because it has a 2, we multiply by 2 each time. So 1 times 2 is 2, and then 4, and then we go backwards, 1 times 1/2 times another 1/2. And since that is negative right here, every y value will be negative. So that's what that negative sign does, makes all those values negative. Next, we look over and we see that we have a -x + 1 in that exponent position. So the -x causes all of the x values to be negative. So we just flip the signs on everyone. So -2 becomes +2. And then we have that +1, and since h is a liar, it's really going to move left. So we have to subtract 1 from each x value. And then, just like the last one, last equation we did, we have another k value, which moves the function. This time it moves it down because it's negative, so that we subtract 2 from all the y values. So it's really not that hard to graph this by just looking at our equation, because we start by multiplying the 1 by that value, so this time it's 2, and multiply everything by the 2, and then we make all of it negative since it's negative. Then we flip the signs here because the x is negative. Then we subtract a 1 because it's in the h position, and then we subtract 2. So you can just go through and add all of your transformations. And when it's really complicated like this, you can rewrite the table like that, where I just rewrote everything from that graph to make it easier to look at. So now we just plot our points like normal. And And you might want to draw your asymptote first so you know what not to cross. So the asymptote is -2 because -2 is in the k position, and that is where the asymptote is. And then we just go ahead and graph. And just like that, we have graphed our function. There are a few common errors when graphing exponential functions. So this first one happens when graphing any type of function, is to always remember that the h value is the liar. So if it has a plus sign, then it means it's translated to the left, and if it has a minus sign, it's translated to the right. That's just how it is. Then the next one is when to know when the graph reflects over the x or the y-axis. So it reflects over the x-axis when the a value is negative. And it reflects over the y-axis when the x in the exponent is negative. And then the last one is on accident, not making the function exponential and just adding the a value to each value. So that would make it not exponential. So you always want to remember to multiply the a value by the previous number. That could just be like a careless mistake that could be made. I think that studying for how to graph exponential functions and just any functions in general are the easiest parts of tests to study, because I don't know, I just feel like they're easy to graph and plot, but that's just me. But it's always good to just practice and do a bunch of problems. And it's easy for these types of graphing problems to just make up equations, put random numbers, and then just graph them. It's not that hard to come up with. And also just memorize the equation y equals a times b to the x minus h plus k. So yeah, that's it on graphing exponential functions. They're not that complicated, even though they might look like it when you've come across an equation with all the transformations. But if you just go one by one with each transformation and add it to your table, then it shouldn't be that scary.